This is video 1.6 on arc length and the area of a sector. These are the objectives. We're going to be looking at arc length, the area of the sector, and we're going to be using radians. We're going to be using radians instead of degrees because a radian is an actual number, whereas a degree is more like a percent in that you reference it as a degree, but if you're going to do math with it, you need to change it to radians. So that's what we're going to do here. To find the arc length, you would use a proportion. You would say that the length of the arc, to the circumference is equal to the measure of the angle to all the way around. So when you do that, when you put in the circumference, and you solve, you would have 2 pi s is equal to 2 pi r theta. Solve for s, so divide both sides by 2 pi. You end up with this formula, s equals r theta, or the arc length is equal to the radius of the circle times the central angle in radians. And so once again, we're talking 2 pi, so we're talking about radians and not degrees. Okay, to find the area of a sector, the area of a sector is this pi piece right here. Theta is a central angle, meaning that the vertex of that angle is on the center of the circle. S is the arc length, and r is the radius of the circle. So once again, if you're going to find the area of a sector, you're going to set up a proportion. So the area of a sector, and there's no, like over here, the area of the arc is, the arc length is s. Area of sector doesn't have a special letter, but it's over pi r squared equals the angle, the central angle there in radians. I'm going to put radians right here, over all the way, which is 2 pi, all the way around. So once again, if you multiply times 2 pi, and I'm just going to shorten that to area, equals theta pi r squared. When I divide both sides by 2 pi, you notice the pi's cancel, but the 2 does not. So the area of a sector is going to be 1/2 theta r squared. Now I could write theta r squared all over 2, but it's the same basic formula. So these two formulas you need, write them down. Okay, the first example is to find the radius of a circle, given that the arc length is 6.5 centimeters long and a central angle has 45 degrees. So to find the arc length is going to be equal to r theta, and I'm solving for r. So I know I'm going to have s divided by theta in radians is going to equal the radius, and that's what I'm trying to find. All right, further, it says that the angle is 45 degrees. Well, I can't use 45 degrees. I have to change that to radians. Now, if you just happen to remember what that is from the unit circle, that is pi over 4. If you don't remember what that is, then you'll have to figure it, and in order to figure it, you would do 45 degrees times pi over 180, and you could do that on your calculator, and that would convert your theta to radians. All right, so what you're going to do is you're going to take 6.5 divided by pi over 4, and that's going to equal r. I don't know why I wrote theta, but it's going to equal r. And so that's going to equal approximately 8.28 centimeters. Okay, on this bottom part down here, it says that the sector has an arc length of 16 and a central angle measuring 0.95 radians. Find the radius and the area of the sector. Okay, so the area of a sector is equal to 1/2 theta r squared. And what has been given is it has an arc length. So S equals 16. centimeters. And then theta is equal to 0.95 radians. Well, I don't have the radius, but I do know that the radius from above is equal to the arc length divided by theta. So when I substitute 16 and then 0.95, my radius is going to be 16.84 centimeters. All right, so now that I have the radius, I can put that in for the area. So I have 1/2, theta is 0.95, and the radius is 16.84 squared, and that's going to get me 134.74 centimeters squared. The next example is to determine to the nearest tenth of a centimeter, nearest tenth, that's important, the arc length of a circle with a radius of 17.6 centimeters that is intercepted by a central angle of 63 degrees. All right, so I want arc length. Arc length is equal to the radius times the angle, central angle, in radians. So I can write this out. Arc length is equal to 17.6, that's my radius, times 63 degrees converted to radians. So I would do 17.6 times 63 times pi, hit enter, and then divide that by 180. And if you do that, and please check me to make sure I did the right thing. Actually, I don't have it. So you figure it out, what it is here. And that would be in what? Arc length would be in what units? So you write out the answer and give me the units. Okay, so to do this bottom one, we're going to have the area of a sector. It says the sector of a circle of radius 24 miles has area of 288 square miles. Find the central angle of a sector. You know, out in, where is that? The panhandle of Texas, where they don't have hardly any rain, out near western Oklahoma and all of that. They have square acreages with round sprinkler systems, big sectors like miles. I don't think it's that big, so this is kind of a big circle, but that's what this reminded me of, this problem anyway. So the sector, area of a sector is equal to 1/2 theta r squared. All right, and so basically this one is just kind of a plug and chug. It says it has an area of 288, and that's equal to 1/2 the central angle. I don't know what that is, but the radius is 24 miles, and that would be squared. Okay, 24 squared is 576. 576 divided by 2 is 288 theta. So when you divide 288 both sides, theta is equal to 1, and that would be 1 radian. Okay, and 1 radian is approximately how many degrees, do you think? See if you can figure that out. And so I'll see you in class, and I'd like to know both things. I'd like to know the final answer for this with the units, and then I would also like to know approximately how many degrees is 1 radian. All right, so I'll see you in class.